Hello. Are we going yet? YouTube looks good. Yep. So we're just gonna give everything a couple moments to get going, and then we'll start. Excited to roll straight into this after Katney and Jeff's stream. It's awesome. It's like Anne got the link. Hey Mark from YouTube, thank you for letting me know that that's working. It looks like the regular chat's working too. It looks like it's a little too wide. I think I can squish that a little. Yes, Juan Carlos, the wall of lights behind Katney is a bunch of strips of neopixels. Hi, Dennis. Looks like she's in chat, can give you more details. So I'm not going to jump straight into this. Thank you, Mr. Certainly. I see you on Twitch, and I see you on there. I think I've got everything squared away where I want it. And we're going to need the terminal here. Hey, Charles. If folks want to join the Discord, you can go to adafru.it/discord. Today is a special day. It's CircuitPython Day, and so that means I have a hard stop. I can only do 2 hours worth of deep dive, which is a lot. But we'll get into that. And then right afterwards, we'll have show and tell. And then right after that, we'll have Ask an Engineer. So lots of streaming today for CircuitPython Day, which is very exciting. As always, if you have questions, drop them in one of the chats and I should see it. Hi, Tinkering Tech. Happy CircuitPython Day. David says, I've often wondered how and where your stream shows up on LinkedIn. You sometimes get comments from there. I wonder as well. I've never actually seen it from the LinkedIn side. It's just like the way that it works is like I'm streaming to Restream, and then Restream restreams it out to a number of services. And like LinkedIn is set up, so I don't actually have any idea where it shows up on LinkedIn. Although I did have a friend of mine who's in our Hardware Happy Hour group say that she's watched it on LinkedIn. So that's pretty neat. Pretty neat that people have seen that there. Mr. Certainly says, I had a work call in the middle of your presentation, so thank goodness they're uploaded as video on demand for later viewing. Yeah, CircuitPython Day is disrupting my work day too. Luckily, it's also work. It's just not my normal Wednesday. It's actually kind of nice because that means that like Thursday, Friday, I have like pretty clear, which is great. But yeah, all this good CircuitPython content for today. Okay, so we've waited a few minutes. It looks like everything's working. Actually, just let me get this tab switched over. And I think I'm gonna have to make this a little bit smaller. So this is a deep dive. I usually do these on, I should say, hi, I'm Scott. I work for Adafruit on CircuitPython. CircuitPython is Python designed for inexpensive computers called microcontrollers. They're really accessible. They're not super powerful, but you can do a lot with them because that's all they do is what you want. CircuitPython is just over 4 years old from the time I started it. Adafruit hired me to work, well, ended up being full-time, but at the time it was just a prototype of getting MicroPython on the SAMD21. If you have questions about that, we've talked about that before in deep dives, but as always, we can cover them again. These deep dives normally happen on Friday afternoons at 2 p.m. Pacific, so this time, but on Fridays usually, unless that I take Friday off and then I bump it to Thursday. I've been doing those kind of since I started working on the ESP32-S2. which is an exciting chip from Espressif that has both native USB, which is a requirement for CircuitPython, and native Wi-Fi, which is super exciting, getting CircuitPython connected to the rest of the world. So these happen regularly every week. They tend to be structured about like half an hour of like overview, whatever I've been interested in, kind of just showing that off, and then kind of diving deep for the last hour and a half. It can end up being more than that as well on like a particular topic. So I've got some overview stuff I want to cover to begin with, and then we'll go into the bug that I want to tackle, which is an issue that I added PSRAM support, which means that we have like a ton of heap memory for CircuitPython, but that turns out that broke SPI. So I want to take a look at that today. It's going to have some discussion about what our options are to fix it, and then I think I've decided which one I want to do, but we can see, and then we'll try to do that in the stream. We do have a hard out at 4 p.m. Pacific, which is just under 2 hours from now, because show and tell is going to happen. So we may not actually get as far as we thought, depending on how much talking I do. The other piece of housekeeping, I just like to warn people, Spook, one of the cats, is not in the window because it's really hot in here, but he is under the desk behind me. He is epileptic, so occasionally he has seizures. I don't expect him to have one today because he's actually like transitioning seizure meds right now, and so he's on 3, so he should be fine. But just in case that happens, I'll just take a break, keep the stream going but mute, and then just watch him and make sure he's okay. It has happened on the streams before, so I just like to mention that. So that's the plan. I wanted to let's see. Bruce S, you just pinged me in CircuitPython chat. If you could do that in live broadcast chat, that'd be awesome. He says that, as an aside, the DMA buffer switching is done in the ESP IDF stuff, so it should work. Yeah, we'll take a look at that. I want to dig into the ESP IDF. So confused. It's all right. It just means that if you're in live broadcast chat, it will show up here. It's all mirrored. I can't do it. But other people will be able to see what you're saying. But yeah, we'll get to that. So let's dive into the random stuff I want to do. So let's go desktop. Spoilers. So first and foremost, I want to acknowledge that it is CircuitPython Day today. This is something we like to do every year to highlight CircuitPython and all the people that are doing amazing stuff with it. You can see here that we have this schedule of all the stuff. None Other asks, when do links for show and tell normally get sent out? I've never tried to join one before, but excited to try today. They usually get sent out just a few minutes before the stream starts. Or even like after the stream starts, the link will be sent out. And if you ever need help with it, you're welcome to ping me as well, and I can help you get in. I'm happy to get first timers into show and tell. Hi Pavre6, thanks for joining us. Okay, so we're most of the way through the schedule today. I just wanted to show it. I've caught most of this stuff and it's gone really well, so thank you to everybody who's hosted. We just have 2 things remaining. We have the regular show and tell. We had a Spanish language version earlier, but we also have an English version of show and tell later after this stream at 4 p.m. Pacific, which is just under 2 hours from now. And then right after that, we have Ask an Engineer. Last year, I think a number of us were in New York, and we just had like a round table of all of us talking about different things. Obviously, I'm not in New York. I'm in Seattle, where I live. And everybody else is also where they live as well. So we're going to try doing it, I think, just using StreamYard with a number of us talking about CircuitPython. We got a bit of a preview earlier in the CircuitPython Weekly with Lamore talking about kind of where she sees everything going. So that was super exciting. and I'm excited. I don't actually know what we're going to talk about, so I'm very excited to see where Phil and Lamore take it and what everybody has to contribute. So don't miss that. That's going to be great, and show and tell should be cool too. I think I'm going to show and tell something I'm about to show you as well. So you're going to get a sneak peek. So yes, the other thing I wanted to say is that there are some other things here. So there's a whole set of Spanish language programming here. So if you speak Spanish, check all this stuff out. There's even a full website for it. Alvaro Fede2 put this on, and he's just been amazing. So thank you to everybody in the Spanish-speaking community. It's been awesome to see that grow. And then the Aberdeen Python user group also has something with some information here. So if you're into that, check that out. I don't know what time that is. Yeah. And then Anne in the chat notes that this Hacker Lab Sacramento stuff, which was going to be kind of the same time as Show and Tell and Ask an Engineer, has they've been impacted by some power cuts due to the wildfires in California. So they're hopefully going to do it at a later time, but definitely not today. Hi, Tito. Thanks for joining. And then lastly, for CircuitPython Day, I want to talk about just the dedication. Yeah, 7 p.m. Eastern time for Show and Tell, which is 4 p.m. Pacific. So this year we're dedicating CircuitPython Day to Lambda Labs. The dedication says, on October 4th, 2020, Beirut, Lebanon experienced a massive explosion that left many dead and injured, as well as leaving thousands homeless. In the aftermath, Lambda Labs Makerspace stepped up and joined the efforts to rebuild the community, including search and rescue, restoring damaged homes, and volunteering, including providing aid tents to help the community find food and shelter, and joining construction engineers to help with the rebuilding process. Last year, Lambda Labs Makerspace was a partner for CircuitPython Day. This year, CircuitPython Day is being dedicated to Lambda Labs Makerspace for all the amazing work they're doing in the Beirut community. If you would like to help with their efforts, consider donating to the following fundraisers. There's Impact Lebanon fundraiser, which is adafru.it/impactlebanon. And the second one is Anera and Global Shapers fundraiser, which is adafru.it/Global Shapers Beirut. So check those out if you want to support them. They've done awesome work. I remember just like seeing these YouTube videos in Arabic come up all about CircuitPython for CircuitPython Day. That was super exciting. So, we consider ourselves Code Plus community, as dubbed by Kattni now long ago. And so we're here to support our community, including Lambda Labs. So please, if you can spare some money for them, these two organizations were recommended by the Lambda Labs folks. So check that out. Okay. Raster says, I feel like I have a lot of reading to do to figure out how to join the show and tell. It's actually super easy. We use this thing called StreamYard. So you should use Chrome, but generally it's just regular web video. What you can do is you find the StreamYard link in the Adafruit Discord server, live broadcast channel, and put that in your browser. It will say like, the typical Chrome will say, are you okay with the web page accessing your microphone and camera? Say yes to that, and then you should see it on the video show up, and then hit join, and you'll be backstage, and then the hosts will be able to like turn your video on for the stream itself. Pretty straightforward. What can happen is that there's a limited number of people that can be backstage, and so if there's a lot of people wanting to be a part of show and tell, it may say that it's full. And in that case, just wait and kind of watch the show and tell, and as people drop out, the backstage will have some free space that you could take a look at. And again, like, we're happy to help you get that going. Hi, Folknology. Thanks for joining. Okay, so let's dive into some random stuff. One thing that's not related, but this is a topic that I've covered on the stream before, and I just wanted to update. Hi, Stephen Nelson. Doing well. Hello, YouTube chatter. This is a project. I live in the U.S. and we have an upcoming election in November. And one thing I wanted to make sure is that people would know when voting deadlines related to that election and further elections are done. So I made this project called electioncal.us, and there's a Twitter account that is electioncal_us, and I just got it working so that it will tweet out images for different states about when the deadlines are. So you can check that out now. I'm running it manually still, but it's a lot of progress. So just wanted to shout that out. If you're in the US and you want to know, like, when is the deadline for getting your application to vote by mail, or when is your deadline to register, or when is your deadline to actually get your ballot in. Those are all sort of things we cover. All the data is open source, so you can check that out as well. So just a quick update on that. There's this issue. Actually, since I'm not talking CircuitPython quite yet, let's actually skip to this other thing. So I think I've talked about some FPGA stuff that I was doing, and I've been working on laying out a board. So this doesn't directly run CircuitPython, but the idea would be that, actually, let me show 3D viewer. So the idea is that this is a stemma QT board. So there's two stemma connectors, here so that you can daisy chain. And then it would be 2 power pins and then 8 pins that you could just use generically. Obviously, I'm not done with it. It's very ugly at this point. But it's using an FPGA that's super basic, pretty inexpensive, and you can program it over I2C. So you'd be able to do everything you want over just the stemma QT. And then Mark Olson, who's in the chat, will also recognize this fingerprint here. Footprint, not fingerprint. It's for the debug edge stuff that me, him, and Nitz have been looking at. It's a no cost way of allowing debug access to a board. So one of the challenges with the low level debugging pins is that you don't really want to have to use them day to day, but if you mess things up with the easier way to load them, so like in this case, loading new code over I2C, if that messes up, this is the debug edge is kind of your out and your way to fix it. So that's what this is. This gives access to the JTAG headers, which should be like always available. And so the way that it works is, I don't have the connectors here with me, but there's just a connector that you would slot on here, and then it would slot into another board on the other side. So Mark's done a great job designing it. I don't have the host one super handy, but on the target side, you get this little arrow into this chip, and then on the other side, you get a spider that points out for debugger, which is really, really clever and really awesome. So I'm excited. This will be the first board I've designed with it. Obviously, I'm not done. I needed to figure out how many capacitors to put for the FPGA. And then these are 2 LEDs as well. So I'm working on that. It'll be a stemma QT FPGA board. And this is what I'm planning on showing at Show and Tell in a couple hours. So I've been working on that. And there's the PCB lab. That'll be open source, of course. And it's 16 FPGA pins with the JTAG pins as 4 of those as well. So working on that. Okay, so getting closer to on topic. And if you have questions, feel free to drop them in any of the chats. I think I should be able to see them all. Nice. Mark has the adapters and has 2 boards coming on Friday, so he'll be able to test it out as well. So we've had this issue in the ESP32-S UF2 repo. This is UF2 is the bootloader that we typically use for Atmel SAMD stuff. It's the thing that shows up as like cplay boot that allows you to just drag and drop the UF2 bootloader over. David G says, it's great to watch the CircuitPython evening and night. Maybe I'll watch the recording. Is there going to be a playlist? That's a great idea. We should do that. So yeah, I'll try to make a YouTube playlist for CircuitPython Day 2020 and just put them all in order, so we can relive the experience. Okay, so the UF2 bootloader is something that we really like. It's the drag the UF2 file over and drop it onto the hard drive to get it to flash. That's not typically how ESP has its code loaded, but we've created a UF2 bootloader for that. It's kind of interesting in that it's actually kind of just a regular application, because there's like ESP IDF stuff that runs before it. But one thing that we wanted to figure out was like the partition layout that would happen. So like the UF2 bootloader would actually dictate like how much space, and it would dictate how much space the actual like user programs have. So we have some discussion here. Microdev it's TAC, who works on Tiny USB for Adafruit, Microdev, who works for Espressif and has been doing the Arduino stuff as well. So we have a big, long discussion, but I think we've kind of concluded the partition layout, which is exciting. And hopefully what you'll see in the next week or two is that we'll shift from the like download CircuitPython or like use ESP tool to flash it onto just the regular UF2 process. Basically what we'll do is we'll just give you a like, here's how to get UF2 on it, and then once it's on it, you're good. And that just reminded me, like, if the double tap to reset doesn't work, how are you going to get to UF2? So we'll have to make sure that we can reset and stuff. So there's more work to do there. My Featherwing adapter does have like the resistor capacitor thing to do the double tap to reset, but I don't think that's checked in. Anyway, so progress there, which has been great. Okay, so two other things. I've been working on the native Wi-Fi stuff, and that's what we did last week. Actually, it's funny, right? Because I normally stream on Fridays, so it's about a week's worth of work. But we're streaming earlier here, and I streamed earlier last week, but I also took Friday and Monday off. So I've only had actually 1 day of work between my stream and now. But what I did in that 1 day of work is, one, on the stream last week, I actually replied to Dan's feedback on the native Wi-Fi PR. And where we left it was I needed to actually test it to make sure that I hadn't broken it with the changes I made. And I tested it yesterday, and it turns out I had broken the Room version, which is the version without the PSRAM. Somebody talking to me. Lucian doesn't realize I'm streaming. Yeah, so I got through all the feedback for Dan, but I didn't test it. So yesterday I tested it and realized that it didn't work without the PSRAM, because it would allocate but not say how much heap size it was. So that was causing an issue, and it looks like I failed the test. So actually maybe the first thing on the stream I should do is fix this so I can unblock it. The other thing I've been working on is the Adafruit requests library. I've been adding HTTP 1.1 support and socket reuse to go with that. It also changes the way that we parse JSON. And so it reduces the maximum amount of memory needed by the JSON stuff. And it does that because it allows the internal JSON parser to fetch each character as it needs it, rather than needing a whole string up front. So this is an exciting change, but I was testing this. I was trying to take an existing PyPortal project and just replace the requests to the library, and it didn't work. And Foamy Guy actually tested it and found it as well. But basically, there's a couple weird things with the socket implementation of ESP32 SPI. One is that if you're connecting to non-SSL or a non-TLS server, you actually have to give it to the IP address, not the host name, which is totally random, and the code on the Nina side actually looks like it should work, but it doesn't, so that's strange. And then the other thing is that the current socket API for CircuitPython takes in a mode into connect, which is not standard CPython socket stuff. So I've got to do a little bit more backwards compatibility work on the requests side before that can get checked in. And Brent also got back to me today, which is great too. But we're not going to do that today. I think I do. Let's just take a peek. What I want to get to is the SPI PSRAM stuff, but I actually really bothers me that this test is failing. FaZe asks, what are you explaining? I'm explaining all that I've worked on in the last week, or last few days, and we're going to talk about why this test is failing on my pull request to add native Wi-Fi support for the ESP32-S2. So let's, this is a standard pull request. Let me just give you the lay of the land. And it's like super hot in here because I have the window closed and the door closed because I'm talking. The window is closed because there's wildfire smoke in Seattle here, so I don't want smoke coming into the house. Okay, so what we're looking at is this native Wi-Fi API with ESP32-S2 support, something that we've DCD says, love to learn more about GitHub CI. Great. Let's talk about it. So this is the pull request that I spent a lot of time on this series of streams adding. It's like getting closer and closer. Dan had gotten feedback to me, and I got back to all that feedback. I tested it on both the Rover and the Room Salo modules, but I had to fix that, so I fixed that, and now it looks like we're failing. So the way that it works is that we run 3 tests always. We always run the MPI cross Mac build. We run this pre-commit check, which checks for like trailing white space and things like that. And then we run this test job. And what this does is it builds the Unix version, which is like the version that will run actually on Linux. It runs a bunch of tests that are in Python and compares the output to CPython. And then if that passes, it then builds all of the individual versions of CircuitPython for all 150 plus boards that we support for all of the languages that we support. That is a big task. It takes a while. And so what we do is we block all that subsequent stuff based on this like sanity check pass first. So that's what's failing, and that's why this really bothers me that this failed, is that we didn't get to the point where it actually built a lot of stuff, which is usually where it actually fails. So what I'm going to do to figure out why it failed is I'm here at the bottom of the pull request. I'm going to hit details. And now I'm going to scroll down until, of course, this will be a quick fix. Okay, let's just, can you read that? Should I make it bigger? Let's just go over this a bit. So these are the individual steps that happens. So it sets everything up. It prints out, like, you can print out information that GitHub's giving into the script. We're checking out CircuitPython. We're checking out the submodules. We're printing the git describe, which is like if we built versions, this is what the versions would show. We're setting up Python for testing. We print out the versions of everything, which is really handy if you have a problem. We run MPY. We build MPY cross for Unix because we take Python files and embed them in CircuitPython firmware, so we need to know that. We build the Unix port, and then we run all the tests. And you can see here that they're like basics/assign1.py. And these, we all inherited these from MicroPython. They did a spectacular job of unit testing that core, what is it to be Python part. That's why they've done that's one of the reasons they were able to do such a great job of making MicroPython and by proxy CircuitPython really feel like Python, because it literally is checking the implementation of the output of MicroPython for tests with the output of CPython. And then they have versions of it for like native emitters and the MPY stuff as well. And then this stubs here, this is a CircuitPython thing. All of our documentation is done inline in our C code. And so this step takes all of that documentation out of the C code and puts them into separate Python stub files, which are these things that end in PYI. And the PYI files are a standard format, so they can be used by any Python editor to do like code completion and sanity checking and stuff, which is really, really handy. Upload artifacts, upload stuff to GitHub. So it shows up here at the top once everything is done. We build the documentation, so this is the equivalent to like the read the doc stuff. We just make sure that it works. And then we run this translations check. We do a translations check, a new boards check. This is to make sure that like there's no new boards that got added in the wrong spot or haven't been added. And building more MPY crosses. So what we failed is translations. This is very, very common, and it happens to the best of us. But what we try to do is we try to keep this locale/circuitpython.pot file up to date as we add strings that should be translated in other languages. One thing that CircuitPython does that MicroPython and other implementations, including CPython, don't do is that we will translate error messages for folks. So if you get an error like syntax error or a Bluetooth error, we actually translate the little sentences or phrases that you get with those into different languages. And the idea is that those strings you shouldn't ever change the way your code behaves based on. But by translating it, we're making it more accessible for people who may not be native English speakers. And so what we're trying to do, what this check is doing is it's just making sure that this POT file, which is like the template file, just includes every possible string. And it doesn't, because I must have added an error message. In fact, I added a safe mode error. So it's really easy to update. I'm in my native Wi-Fi branch of CircuitPython. And you actually just move to the top level, and then you hit make translate. And what this is doing is it's going all over all the C source files and finding all of the different strings that we want to translate, which they put in a translate parentheses like function call that this actually can identify. And now that we see the branch coloring has changed from green to red, which means something's different. We can do get status to see what it is, and we can see that the file that it complained about on the CI is marked as red. We can do get diff of that, and we can see that it indeed added the one message. I added a safe mode scenario for the ESP where it tries to allocate the heap within the ESP IDF, and if that fails, then you'll get into the safe mode. So it won't try to run any code, and it hopefully won't crash. It will just tell you like, hey, this happened. So that's what we need. And I'm going to have just a bad commit message. Add safe mode translation. And this will be good to do now because it'll give the CI time to build every board and hopefully build every board and make sure that I didn't break anything otherwise. The advantage of building every board is that Johnny asks, why have the term CircuitPython in the error message? That's a good question. I guess I just took it from the fact that I didn't think too hard about it, for one. But if we look at where it comes from, like the other messages also had it. It's a good question though, because I'm all for open source, but you may know that I'm pretty stingy about branding. Like I want CircuitPython things to come from the CircuitPython repo and be versioned with CircuitPython and make sure that it works with CircuitPython tutorials and stuff. So I would actually, one thing I'd like to do is actually remove the use of the term CircuitPython from most places, so that if you have an unofficial build from somebody's fork, it actually will then use a different name. And only the builds from like this pipeline would be branded CircuitPython. I just haven't had the time to do it. But yeah, I think I just got it because like I added it right below here, and it's like the CircuitPython heap was corrupted and the CircuitPython core code crashed hard. And then there's MicroPython related ones as well. So yeah, we should probably get rid of it. Right. Charles points out in Discord that safe mode messages are unique to CircuitPython. That is true, because CircuitPython is the only thing that has this notion of safe mode. And for those of you who don't know, safe mode is something really bad happened, and we wanted you to have the ability to change your code and potentially fix it, even though something really bad happened. So what we wanted was a mode that we could start up in CircuitPython. So something bad happens, we reset usually. And then what we do is we reset into safe mode, which spits out a warning, provides you access to your code on the drive, but it will not run your code. It will not run boot.py. It will not run code.py. And that's because it is optimistic, I guess, in thinking that it's the user code that caused a safe mode crash. So as a user, you have some code that does something particular, and it tickled some errors in the low-level C code of CircuitPython that caused a pretty bad crash. And so we wanted a way for you to like recover from that. So that's what safe mode's about. You can kind of see here kind of all the different reasons we may safe mode. Unexpected Maker says, oh, that's pretty cool. I didn't know about safe mode. Good. It was something that we added with the idea of like, you should never get here. I feel like we even say that, like, we have safe mode, but you should never hit safe mode. Like, most errors in Python should throw exceptions that you can handle and that are not like fatal. But that's not always the case. So let's just go over these since we're in safe mode land. Let's just talk about this a bit more. Especially because some folks didn't know about them. So there is two ways of getting into safe mode yourself. Manual safe mode is, I think, on the Circuit Playground Express. I think it's the only board you can do it, but you can hold both buttons down when you start it up and it'll start into safe mode. There's also a way with at least the SAMDs, or no, it's on every CircuitPython board, but CircuitPython, when it starts up, will actually delay for a certain period of time, and if you happen to reset during that delay, it will actually stay in safe mode as well. So that's what manual safe mode is, and then programmatic safe mode is, I think you must be able to, like, from CircuitPython, say, reset, and you can reset into safe mode. From the REPL or from your Python code. So unanticipated does not equal unexpected. Yeah. So I was doing some NeoPixel grid stuff, and I ran into this issue that the timing was wrong, which turned all of the NeoPixels on full white, which is like sucking a ton of power and caused the power to dip. And so brownout is one way that it can happen. And it happens actually a lot for me as well, of like when I'm plugging into USB, you might see like So if you ever see a CircuitPython board with a RGB status neopixel, if it's ramping yellow up and down, that means that that means it could be safe mode, or that's what safe mode is. So the neopixel or the status LED will ramp up and down green if your code.py is done. But if it's yellow, it means that it's in safe mode, just waiting. And David G says, with my 64 by 64 matrix controlled, I fell in safe mode frequently while developing. Yeah, that could be it. Unexpected maker. So I'm not an anticipated maker. Is there a way to force it into safe mode to see? Yes. Yeah, so if you start up and you have a status LED, it will actually briefly show yellow as you start up. And if you hit reset while it's yellow, although this is not true on the ESP32-S2. And in fact, maybe we should just do that today. I don't think I don't think safe mode works on the ESP32-S2 right now. At least in the case where it has to restart. I did successfully... Yeah, it's probably not that interesting. But I did have to test this with the heap thing. Let's just do that. We can do that. Since we're... You know, we like our tangents. It's fine. Okay, so I've got just a Rover Sallow with my feather wing on it, and I'm just going to plug that in. I was actually going to use it for the SPI stuff, so. Never seen a flash of yellow. Yeah, ESP32-S2 doesn't do it yet. This is something I have to do, actually. Because the way that safe mode works is that it has a piece of RAM where it stores a value, and it will actually fully reset everything otherwise. So I haven't made sure, like, it literally will go through the bootloader again most of the time. There's a way for for the manual safe modes. There's a way to like say when you're booting up. Oh gosh, a tangent. Pavre, are you like so excited, so surprised that I hit a tangent? Yeah. So I was gonna show it, but my USB. Let me reset my hub like always. All right, CircuitPy is up. David G says, my problem was to get out of safe mode, and that means unplugging both the 5 volts and the USB. Yeah, if you hit reset, that should be enough to get out of safe mode. Microdev, happy CircuitPython day. I said I had a hug report for you earlier for adding the temperature sensor support to the ESP32-S2. Okay, an unexpected maker has a... I meant to ask you offline a few days ago. I've lost track of the state of everything in terms of which branch all of the new features are in. Can you get a quick overview of what feature is in what branch? PSRAM and Wi-Fi specifically. So PSRAM is in main. I don't think it's released yet. I don't think it's in 6.0 Alpha 3. And then Wi-Fi stuff is in my native Wi-Fi branch. But those are the only 2 branches you should have to worry about. PSRAM in main does not work with SPI right now, which is what I was hoping to fix today. And I'll at least talk about it today, but maybe fix it tomorrow. Yeah, and if people didn't get it, Microdev added temperature sensor support, which is awesome. I probably have the wrong. Okay, so this is normal. I don't think safe mode, manual safe mode. I don't think it'll work. Dot. On next reset. microcontroller run mode dot safe mode. So this would work on a SAMD, but I don't think, like, we don't have the resetting stuff working on the S2 right now. Yellow to blue to green during boot. Yeah, so the yellow bit is it solid green? I don't know what the blue is. The yellow is the point where if we had the if we had safe mode working, that if you hit reset during, well, that's not true. I have to think about that. The reset stuff with the S2 is really tricky because the reset button literally turns the power off to the whole chip. So that may not work, and we should probably just turn that off. But on other stuff, like there's that yellow gap, the yellow LED gap, where if you reset, like on a SAMD21, it will go into safe mode. Let me just, I'll just cheat it. So we can just basically mimic the scenario for the safe mode which I did just to test. Yeah, and David G points out that same command that I just showed on next reset, you can give it bootloader, which will is a way to get into the bootloader without having to use the reset button at all. Microdev says maybe the boot button can help for safe mode. The boot button is used by like the built-in bootloader, so I'm not sure. I mean, maybe, but I really wanted to get away from the boot button as well. I know a way to double click into the bootloader, but that's not safe mode. Because we just, like, for resetting in the safe mode with the reset button, we like replace the in-memory value. We do the same trick that the bootloader does, but we can't do that with the S2 because we literally have 1 bit of memory to do the double tab. Okay, so let me just build this, and oops, I'm in the wrong folder. So we're gonna go down this tangent and just show off the safe mode for this. Folknology says the boot button doubles as a user button, so it would work nicely. Yeah, I guess what we could do is we could have the boot button, we could check the boot button for that delay and see if it goes down at all during that time. It's like slightly non-standard, but it'd be better than not doing anything. Should file an issue for that so we don't forget. Silly. Okay, so I added, let me pull up text. Oh, spoilers. Notes to myself. So the thing I was looking at is in supervisor port.c. This port init function actually is able to return a reason to go in safe mode. This is how the manual safe modes work on a kind of per port basis. So here we can see that heap starts as null. If we have configured SPI-RAM, we use that. Otherwise, we try to do this malloc, which uses the ESP IDF. So what we can do to mimic our safe mode is just comment this out and save the file. So now we'll get to this point where heap is still null and we'll return the safe mode type. So here's the version that doesn't have that. So let me turn my USB on. So we see here that, like, if I hit Control D, it runs my code.py, which is just my Wi-Fi test thing. Generation says, can you program / flash an Adafruit module with another Adafruit module that will be served as a programming unit, which itself flashed just one time with a PC? Can you attach a keyboard and a screen? So yes, you can program one Adafruit module with another. Not really from CircuitPython yet. I did start a JTAG. Oh, got a crash. A JTAG library that would allow one Adafruit board to program another, or any CircuitPython board to program another. But it's pretty basic. And you can't do the USB stuff because CircuitPython doesn't have a USB host yet, which is also why you couldn't attach a USB keyboard to it. We do want to add it, and TAC just was doing some tiny USB support for hosts, but we're not there yet. We do have screen support already, so I think that's one of the places we have to look at is adding the USB host support so that you can connect a keyboard. I would really, one of my holy grails for CircuitPython is HDMI output support. I would love to basically make a modern day C64 where you have an inexpensive computer that is a single task. I hear all you Raspberry Pi people being like, we already have that. But I would love to have a really inexpensive single task computer, kind of a la BASIC, where you just have a USB keyboard, plug it in, and HDMI out to whatever TV or monitor you have that just runs CircuitPython. I think that would be amazing. Okay, let's rebuild and reload just to show off the safe mode thing. And then we'll get on to the SPI stuff discussion. Anne says, I want that too, the C64 things. Yeah, if anybody knows an easy way to get HDMI support, Folknology says the Black Edge board I'm working on will do the HDMI stuff. And David G says the Maximite Color 2 running CircuitPython rather than HDMI, or rather, it's running CircuitPython rather than BASIC. And then Mark says the STM32F7 LTDC output with an HDMI converter. Yeah, everybody's on board with this, I think. Mark Gambler says, I grew up on the C64, really taught me everything I knew to start. David G says, VGA support and convert to HDMI. And Bruce S points out that I'm doing FPGA work. D-Lan says, HDMI out would be really cool. There's a ton you could do. Oops. There's a ton you could do with it besides just acting as a computer screen. Bruce S says, I grew up on carrots. DCD says, I would guess your FPGA board could do HDMI. Problem is, FPGAs are not that cheap. But yeah, I even did the math. I think what was I going to do? Ryan G says you could port CircuitPython to the Circle bare metal framework for the Pi. Can you link me to that? I have not heard of a Circle bare metal framework, but I would love to be bare metal on Cortex A series chips. So yes, if you have a framework for doing that, please point me to it. I would love to see CircuitPython on a Raspberry Pi as CircuitPython without any Linux, which would be kind of mind-blowing. But I would want the same experience, right? It's like plug into the USB, you get a drive, you program it. David G points out there is MicroPython bare metal on the Pi. Yeah, there's a fork that has bare metal Pi support. Yeah, I think that's a great route. I mean, Raspberry Pis for $5, like, it's hard to ignore that as an option. One of the challenges I think would be for the HDMI stuff is supporting the graphics, like bare metal graphics support. Pavre says, I grew up on ZX Spectrum. That would be awesome. All right, well, we have lots of folks here that want to see this happen, so I challenge you. If you need help getting it going, let me know, but we can make this a reality. Okay, so It still works. What happened? Did I not save the file? Or do I need to rebuild? I commented it out. How does it have a heap? Oh, you know what? I'm on the wrong board. I'm on the board with PSRAM. Instead of switching boards, because I'm lazy, I'm just going to comment this out. Pavre says, sure, I'm in. Yeah. Ryan G, point us to that framework. That might be a great place to start. Cortex-A support would be amazing. Like, gigahertz? Ah, thank you. Copy. Ah, and Mark links a DSI to HDMI adapter board. Yeah, I know that's what they the STM32MP1 has a converter from DSI to HDMI. I know the chat just like blew up when I mentioned that. I forget who it is. I think it might be Kmatch. Kmatch actually has like a basic editor for CircuitPython, I think, as well. The other thing we need help with would be, well, Bluetooth HID support shouldn't be too hard. So you should be able, like, we'll need a way to inject like keystrokes from Bluetooth keyboards in, but that should be doable. And then USB host would be amazing as well. Mark Ambler says, I'm pretty sure my C64 is still at my mom's. Yeah, I actually, the cat's not in the window. Let me switch to cat cam. I'll show you where my C64 is. It's right. I have it like, so this is a bookshelf right next to my desk. So there's my C64. I've never gotten it working because it doesn't have a power supply. But it's kind of my inspiration, along with, you can see SimCity there. And then I've got down here this, it's a Atari 800. I think that's what it is. And then this weird like serial comparator thing. Okay. Back to cat cam. Minus cats. Okay, back to my desktop. Tito says, I'd love to see CircuitPython support the blue pill. Isn't the blue pill... I don't think the blue pill is powerful enough. I think that Higher Effect wanted that too, but it's not... Yeah, it's not enough RAM and not enough flash. I have that Lego set. I have a Lego set over there? Yeah, it's a bummer. Higher Effect was just working on STM32F1 support, but for ones that have more RAM and flash. But the blue pill doesn't have enough RAM or flash. Generally, we need 32K RAM and 256K 256K flash. And of course, DCD linked me to a C64 power supply. I think I have all the parts to put one together. I've just not done it. This is all of these old electronics is actually the reason I'm really interested in FPGA stuff, as a way to like do parallel interfacing. Pavre 6 says, cool collection, Scott. Thank you. That's just a little bit of it. I have a whole bin full of Game Boys, which, yeah. If folks don't know, I was trying to get a Game Boy cartridge that ran CircuitPython, but it's not reliable yet. Ah, that's right, the duck. Thank you, David. Yeah, the Cyberduck. And yes, I think the black pill is already supported. Ah, the Lego set was the Seattle Space Needle thingy. Oh yeah. My wife's sister got that for me. Okay. C++ bare metal environment for Raspberry Pi with USB. Very, very cool. I'll have to look at this later. I think we wanted to actually do, we wanted to support tiny USB. Johnny's reminding me I have an hour left. Thank you. Johnny, you know well enough that I don't always manage to get what I want. Yeah, I do have an NES in my other room. I wanted to start with Game Boys because Game Boys are nice and contained and they work well. Like, you don't have to worry about interfacing an old TV output to a new TV input. So yeah, Game Boys were definitely the place I wanted to start, but I wanted to be able to do like all sorts of cartridges. Yeah, Bruce S says this show is all about the diversions. I swear I do some work during this show sometimes, but this is a special CircuitPython Day one. So if you have topics, I'm happy to talk about them, and they are kind of CircuitPython related. Okay, so I was just gonna show this off. This is what it looks like if you're in safe mode. I remembered what I was doing. So if I hit Control D here, it's gonna say, it shouldn't say this actually. This auto reload on message should not be showing up because it will not do anything. So that's a bug. That's a getting started bug. Pavray6 says, we are on a super tangent ride. Yes, we are. But it says, yeah, running in safe mode, not running saved code. You were in safe mode, something unanticipated happened. This is the specific message, says CircuitPython was unable to allocate the heap. Please file an issue with the contents of your CircuitPy drive at our issue link. Mark Olson has a topic, CircuitPython based on Zephyr. I've played it with the MicroPython version and it's amazing. We so need that. Go ahead and add it. I tried to convince Maureen, who added the Zephyr port to MicroPython, to do CircuitPython, but they were only interested in MicroPython. But yeah, I'm game for it. As is tradition. Cool. Okay, so that's what safe mode looks like. And Mark, Johnny's rooting for you to do the Zephyr port for CircuitPython. I thought it would be handy to just actually go over this file about all the different ways that you can get into safe mode, just because we haven't talked about it. We're here, so we might as well. So manual safe mode is when you hit the reset button in that window. Programmatic safe mode is the microcontroller reset into safe mode thing. You can do it with brownouts, and the way this behaves varies a little bit between like the NRF and the SAMD. I don't think all ports support it. Certainly ES2 support doesn't support it yet. But that's we've had some issues with this one actually because people are battery powering their projects, and the brownout detector has catches it as your battery droops down, and then it charges back up, but it starts you in safe mode. And so there's some weirdness there where we need to actually, it's not even that, because if your power is low enough that the RAM loses values, then safe mode won't happen. But I think it's actually on the way up. Like as it charges, it like doesn't quite get above the threshold. So we've had lots of problems with that. And this is probably the most common reason people see safe mode. Heap overwritten is we have some values between the stack and the heap that we make sure don't get overwritten, and if they do, it's bad. Hard crash is a on ARM, it's a hard fault handler. So if we get into the hard fault handler, we'll actually safe mode reset and get you back. And this is the reason that inspired safe mode in the first place, was oh, what happens in this case where like something really bad happened and the code is just like off in the weeds. How do we handle that? So that's what hard crash is. NLR jump fail is a Python thing where it's like MicroPython thing where it's trying to unwind the stack, and it like if the stack is corrupted, it can't do that. I don't know what fatal error can. I don't know what that can cause. GC alloc outside of a VM is pretty common when you get you try to raise an exception from code that's both used by CircuitPython itself and by user code. If that code tries to raise an exception, but we're not actually in a VM at all, this will happen because it's trying to allocate memory for the exception, but the heap doesn't exist, as it says. Nordic soft device thing, flash write failure, memory management is, I think, only for the IMXRT, where it can actually like set some boundaries and detect when you're not following those boundaries. Watchdog timer is only for if the watchdog is actually enabled, I think, as well. So that's an overview of safe mode and the ways that we do it. But the goal is that like safe mode is only used for things that are like truly, or what we like not handled or unrecoverable, where you actually just want to reset and ideally not run the code that caused it in the first place. Okay, so that's safe mode. I'm going to leave this circle thing up because I want to read more about it. But if folks know the Cortex-A series stuff, let me know. I would love, love, love. I want to look at this, but I would love to have Cortex-A support CircuitPython. Let's just circle back here. So this is back to the native Wi-Fi PR. Generation asks, ever heard about CircuitPython? Whoa. I'm doing a lot of streams today. Brain's not here. Ever heard about Bluetooth CID numbers on a low power network? I have not. Not sure what CID means. Maybe somebody else has. Pavre6 is A13 all winner. Sure, why not? I think one of the challenges with the Cortex-A series chips is that like the hard part of porting CircuitPython is not the core itself, right? It's all of the peripherals around it. And what you'll find, or what I've found when I've looked into Cortex-A stuff, in this hopes of finding an HDMI output, is that a lot of them are like NDA'd, so you can't just find open datasheets for them, which is a huge bummer. The one that I was looking at was like the Rockchip RK3399 is the one that I kind of had my eye on. Like I even have some of these. I wanted to do some bare metal stuff with it. AP Killer 10 says you should be able to at this one site according to some standard. Not sure what you mean. Okay, let's check on this native Wi-Fi PR that we fixed earlier and just see that it's going. Yep. So it says 141 successful, 17 in progress. So it's just about done. And if we hit details again, we'll see that on the left side, there's a whole lot more. And there's a whole lot more, one for every board. And you can see all the extensive ones passed. So that's great. That's great news. Those are the ones that I would most likely to break. So it's good to see that those are there, and it's just wrapping up the SAMD arms. So that's good news, and I think that's why Dan probably hasn't done my review yet. It's because he saw that it failed. Data sheets, but I look into yeah. Yeah, I haven't been able to find really good data sheets for Cortex-A series stuff. I think a lot of it is also actually companies that create Cortex-A, like they add Linux support or they provide a fork of Linux that you can use. And because it's like the canonical thing that you would run on it, there's not as much incentive for them to actually document the peripherals, because as long as they can provide you software in the form of like actually source code or just a binary blob, then like that's usually what people need. which isn't good for what we're talking about. Okay, so an hour and 10 minutes in, let's talk about the main topic that I want. And of course, if you have questions and want to distract me, feel free. Obviously, I'm open to that. AP Killer says, I find some lazy Android images for BPI, but I need to do an MMC flash to get out of the newbie state. Yeah, that's the other thing is that I don't really want a board that requires an SD card. I think it would actually, like, I would like just native CircuitPython on stuff, which is one of the wild things is that theoretically, like, these chips, these boards, I think, have, like, SPI flash to store, like, the core ROM that just gets everything going. Like, what if that SPI flash just stored CircuitPython, which is kind of wild. But I don't know much about Cortex-A's, obviously. Okay, so this is the issue. Distractible as always. So Emard was testing stuff out, which is awesome. Thank you very much. Says I renamed it to Confirm SPI Works. I forget what it was originally titled. But it says, hey, I'm like trying to port this JTAG programmer over to CircuitPython. It doesn't work. In the later versions, the PSRAM appears, which is great, but now SPI is broken. And I need to switch between bit banging instead to make it work again. So I said, oh, it's possible that the external RAM prevents the DMA. And they say, I'd say SPI doesn't work at all now, but I don't know the details. What I see currently is that SPI doesn't send correct data I pass it. Probably it sends all 0 or all F and reads all 0. Only the bit bang part is working. And it worked with MicroPython on the ESP32. I need to retest. Like, I'm not surprised. Like, the S2 is still really early. And they go and confirm it. And then I think Jerry somewhere also reproduced it. So there's a couple ways we can fix this. DCD says BeagleBone boards can boot off flash. Shaking my head, yes. Let's do Cortex-A. How awesome would that be? And like, it is kind of funny that like there's the giant board and it's got a SAM A5 and it's actually like 400 megahertz, so it's like slower than an IMX RT in terms of clock rate now, which is kind of wild. Okay, so the reason I think this is a DMA issue is that when we were implementing SPI, I think we saw that only certain SPIs can DMA from the PSRAM. And so this like is not a surprising issue to me. But I kind of pushed it down that road with the PSRAM. But now that I've enabled PSRAM, I kind of got to go back and fix this. So my higher level goal is just to get SPI working with PSRAM. That's the baseline, right? The second question is how do we do that? And I think more importantly, the question is, are we okay if DMA doesn't work anymore, or DMA is not used anymore for that case? And I think that's going to be the simpler option. The disadvantage of that is DMA is great because it means that something else is worried about copying data from memory to the peripheral, which means your CPU can spend all its time doing something else, which is what we would use if we could, or when we could, we will. But it's not that useful, or not as useful for CircuitPython, because our current API makes you wait until the transmission is done anyway, which means you can't really do any CircuitPython stuff at the same time. You can do, like if you have audio playing, that will still work. If it's on a separate SPI bus or getting its data from a separate SPI bus. But you can't do other Python code at the same time your SPI is running currently. So it doesn't matter as much that you're using DMA, which is why I think that's my pick, is to just change the code so that in the case that PSRAM is used, we just don't do DMA. And there's a buffer on the peripheral side of like 64 bytes of data to transmit. So if we could get it to a point where we're just like filling it in, like copying out a RAM with the CPU and filling that FIFO in, like that would be pretty simple. So that's, I think, the option that I would like to pursue. There is a second option, which I've talked about with some folks already, and that second option is copying the memory, more specifically moving the memory. So imagine we gave you this buffer in CircuitPython. MicroPython runs it too. You created this byte array. It's 4K long or something. And now you give it to BusIO SPI and say, hey, write this out. And we say, oh no, like this buffer you gave us is not in the RAM that we can DMA from. But we might have room in RAM that we can DMA from. So I was originally thinking this would be the best option because a byte array is actually kind of like one object, one allocation that wraps just a straight up array under the hood. And let's just look at that since I have it pulled up, or since I have my browser open. And I don't think I'll get to, I don't know, we'll see. I probably should end early just because we're going to roll right into show and tell right after. So I should leave a bit of maybe like a 10-minute gap. So 30 minutes, just over 30 minutes from now. Plus I should save my voice because I'm going to do show and tell and I'm going to do Ask an Engineer. Okay, so if we look at, what was I going to look at? Oh, I was going to look at how a byte array object is actually implemented. So it shares a lot of code with array. So we're in CircuitPython Pi directory. Mark Olson says a toilet break sized gap. Yeah. Opening the door and getting some cool air in here too. Although I do have another glass of, it was ice water and now it's not. Okay, so there's this obj array H. So all of the Python objects moving memory away from the CPU. So this is the C structure that represents a number of array types in MicroPython. CircuitPython hasn't changed this, so it applies. Theoretically, if we went down this road of moving it, then we would start to move away from the way MicroPython does it, but currently we don't. There might be one or two things that we added, but minor things. So this is the struct that is stored on the heap that is the outer layer of a byte array. And then it's doing things like pointing to the type of the Python object. The type code here is like, is it an array of different different types of integers, or is it a byte array, or I don't think it's bytes. Bytes are treated like strings. And then it keeps track of free and the length in elements. So this is like, yeah, my brain is gone. Lastly, it has a pointer to the actual array. And so what I was originally thinking when I was saying we could move memory is what we do is this, I thought, it's not true. I was thinking that this was the only place this pointer to that like underlying memory lived. Where this like void pointer items, the array mechanics could say, oh, you want to move this to a DMA-able area. Let me allocate in this other area the same amount of memory, copy everything over, change this pointer to that other pointer, and then we're good, right? But we're not. We're not for a couple reasons. For one, the CircuitPython heap or MicroPython heap at this level is like basically interchangeable. Like it lives just on the PSRAM, which is entirely not DMA-able. So if we were to move memory from that area to the ESP IDF suddenly we're kind of like out of bounds in terms of like tracking how to free the memory. And that's the first thing that makes this harder to do. Yeah, Bruce says from what I think it does, the ESP IDF SPI stuff does the buffer move. Can you link me to that? So the other challenge here is that we don't actually use the top level. I wrote all this code and I forgot this, but in CircuitPython we don't actually use the top level API for the ESP IDF SPI stuff. We use the HAL layer underneath that because we didn't want the device level stuff. So let's just refresh ourselves on the way that it works. And let's see. So here we are in ESP32-S2, Common HAL Bus IO SPI. There is, where was it? So there's this DMA initialization stuff. So our object, this HAL, comes from self. So self is allocated in PSRAM in this case. So it's allocated on the MicroPython heap. And then HAL context is part of that. We take its address, which gives us the pointer. And then that pointer, we also have TXDMA and RxDMA, which are the like metadata that the DMA peripheral needs to know about what is going where. And then we say that we have one of each. Now, in my experience, if the data itself is not available in, like both the metadata and the data itself need to be in DMA acceptable RAM, which in this case it neither is, because this is all allocated on the CircuitPython heap, not the ESP-IDF heap. So I think that's the problem. And then we enable DMA down here. Theoretically, we could try just setting this to 0 and seeing if it works. It might. And that's kind of like something to consider. If we look at where's our actual write. So write calls transfer, transfer is here. And we can see that we are doing separate DMA-able chunks. Because I think it's 4K a piece. So we actually do a number of lower level transactions, which is actually what I was thinking. But what we could do is, if DMA is not available, we could do the same process but for smaller chunks, because there is like a buffer for the SPI peripheral itself, which I think is 64 bytes at a time. So whereas I think here we can DMA 4K at a time, we could queue up 64 bytes at a time at least. And so I think that's probably our best bet. So moving memory. Moving memory is theoretically doable. There is the challenge of when the byte array goes away, we need to tell the ESP IDF heap, hey, we're done with this memory. So we can't just rely on what it has now to free it up because, oops, bookmarked it. Remove bookmark. We can't just rely on the existing freeing mechanics for CircuitPython because it's outside of the CircuitPython heap. Do you use spymaster.c in the ESP IDF? I don't think so. So what we're calling is we're calling this SPI HAL, setup transaction, prepare data, and user start. So I don't think we're using that, because that handles all the device stuff, and we use that device stuff at the higher levels in CircuitPython, so we couldn't use it. But it's worth actually looking. So let's just see how they do it. Let's pull up the IDF and see. Because if I learned anything from Mark Olson, it's that I should look at the example code in spymaster.c. I think that's in driver, right? Driver spymaster.c. Line 715. Okay. Set up private descriptor. Yeah, so if use RX data. So this is if this is a trick I played. If your data is shorter than 4 bytes, you actually put it in the pointer and just use it directly. This is what I think this is what Bruce is talking about. If the receive pointer is not in DMA capable memory, malloc new memory, and the RX buffer needs to be a length of multiples of 32 bits to avoid heap corruption. So this is saying allocate some memory and make sure that it's DMA capable. If that doesn't work, then we're done and we failed. And then they do the same thing here. But for transmitting, they do a mem copy. So, yes. AP Killer 10 says, I wonder what happens if it's not 32. It's a good question. Defensive coding is hard. Right, so we could do this. And in fact, we could do this. We could allocate and copy every time we transmit. I don't really like that. I guess one question that I have is that whether this mem copy can be done with DMA. I don't think so. So like, if you're already spending the CPU cycles to copy from non-DMA-able memory to DMA-able memory, why are you bothering, right? Like, I guess in this case, where if it is actually asynchronous, like maybe the CPU copies pretty quick and then like it's a little slower to like spit everything else out over SPI. But in CircuitPython's case, like if you're already using the CPU to do a copy, like it's fine if we do the copy ourselves from one place to another. Or if we do the copy from RAM to the peripheral directly, we don't need an intermediate place to store it, I don't think. Unless maybe that's the only way it works. Maybe there isn't a way to do it without DMA, which could be a problem. So set up private descriptor. I think that's called here. Yeah, so here's where it's trying to set that up. We definitely looked at this last time, right? Queue transaction. It's doing some locking stuff that we don't do. But here's like setup device. It's been a while. Been a while since I've been in this code. All right, so let me get my other water. David, are you trolling me? David says, I think you have to implement multiple solutions, benchmark, and then decide on pros and cons. I'm not going to do that. It's not that critical. It's not critical enough that I'm going to implement both solutions. I think I don't think the moving memory thing the moving memory thing is far more complicated than the alternative, which is just don't use DMA. And there's another aspect that we haven't even talked about yet. And Johnny trolls me too. Says also add unit tests. David is on the. I agree with that. He says put the 0 and try it. Yeah, disable DMA and see if it works. That's it. That's a much better option. But before we do that, I think that. Yeah, I don't think we actually have time to do that. That's certainly, I think, what I'll do. But as I was thinking about this, there was one other issue with the moving. I was excited about the moving memory solution. Yeah, Pavre6 says start simple is the way to go as well. I originally thought the moving memory thing was the simple solution, but I remembered about memory view. So Python has a way to share a backing array of memory between multiple objects. Yeah, Bruce S says, this is a funny comment in SPI Hal H. Says, the HAL is not public API, don't use an application code. Yes, I saw that and I decided to use it anyway. But I cannot blame them if it breaks, and I will try not to. And it hasn't so far. Okay, so memory views. So everything I've talked about so far in terms of copying memory around and changing this pointer is like not that hard. So the freeing case, Python objects have the notion of a finalizer, which is code that runs as the memory gets deleted. It doesn't guarantee when that runs, but it does guarantee that it will run. So that's not intractable. That's not impossible to handle. What's a lot harder is the memory view object. So if we look, actually, I think that memory views are just also an array type code. So I think I looked this up yesterday, but memory view copies that internal pointer, which means that you actually get multiple references. So mobs new memory view, you create a new array, and you pass in items. So yeah, so this is the constructor where you give it a buffer, it gets the and the buffer has that internal pointer. It doesn't have the outer object pointer. So what I would basically have to do, I think, in order to make this work, is I would have to make memory view, instead of pointing directly to that array of memory, it would have to point to the byte array object, which then points to the array of memory, so that the pointer to the array of memory is in one location, not a bunch. If at any point we're going to want to move it, we need to have that in one location, which is just not going to happen, which is not something I want to deal with. So I think those are the two main reasons of like the finalizer is gross and not particularly pleasant to deal with, to free when we need to free. I guess I didn't even say, but like you also run the risk of if you do the solution where you're moving it into the internal memory, it's possible that you don't actually have enough internal memory to begin with, right? Like if you have a 100K byte array that you allocated in the 2 megabyte PSRAM, and then you want to DMA that all out, like you're going to have to chunk it up anyway, which I guess we do. So maybe that's a way to go around it. Is like we could have a 4K buffer we just hold on to and copy to. But I don't see the benefit of that. All right, it's 3:35. We got 25 minutes. Is there any other questions? The reason I'm procrastinating on actually experimenting to fix this is I don't actually have a test set up. I do have the Salier. I have like logic so that I can see SPI output, but I don't actually have like a code.py to exercise this, which is why I'm procrastinating. So is there any other topics we want to talk about before I end the stream? And then I'll do this tomorrow when I have a fresh brain. But I want to get this done by this end of the week because it's kind of a bad bug to have. AP Killer 10 says, in modern CPUs and GPUs use special instructions for copying. So like if statements for pointer and pointer to pointer of memory and it's like inception of pointer to pointer. I don't know what you mean. I assume that modern GPUs and CPUs really use like a DMA sort of style thing. I'm not sure what you're referring to. We could go talk about the Cortex A series stuff a little bit more. Or the USB host stuff, which I think is going to be really exciting. So it's under tax. I think I just saw it go by. I think there's certainly an open issue for it. So if you want to get into USB, having USB host support would be amazing. So this would, yeah, there's this rework host stack, and I think hopefully no, he didn't. Next release in 2018. I think there is a closed PR that he merged. Yeah, update host. So he's working on it. But yeah, being able to read like a mass storage device or read like a keyboard would be super cool and be like half of that equation of like input. I actually hacked it. I used to have a Model M keyboard I found at the... I hacked it together with PS2 so I could read keyboard inputs over PS2. And it was actually not that great. It was actually not that great to like just get REPL access. Needed something more like what Kmatch is doing with a proper editor. So there's definitely work on the like user side. Like once we get to that point where it's fully standalone. So there's work there to do there. And the oldest bug CircuitPython has, if I can get people to want to contribute, it's like issue 260 or something. It's the oldest open issue we have. Has to do with, yeah, 231. Opened in September 2017. Wanting to be able to get, is there a playlist for the deep dives? Yes, there is. And it should be up to date, although maybe I forgot to add one of the last ones. Whoa, it's so like Inception. Let's see. Yep. There you go. Yeah, so this is the oldest open issue we have, and it was about how do I get a serial connection between my computer and CircuitPython that I don't have to share, with CircuitPython, because CircuitPython takes that serial connection over USB, and it looks for certain characters, like the character for Control-C, the character for Control-D, and does something based on that, which means you can't just shove bytes down that, because CircuitPython's going to do it. So there's a big, long discussion about this, and we've kind of hacked it or made it better where the other thing is that you couldn't you had to block, like waiting for a character was blocking. So we did add later on the ability to see like, are there serial bytes available? And then you could call input or read. But it's still not ideal because it still has that byte filtering. And so the real solution, I think, for this is adding the ability to change the USB descriptor in your boot.py. So boot.py runs before USB is initialized, which means that you could say in boot.py, here's what I actually want to pretend to be. So turn off mass storage, which is something people want, but I don't want to have by default. I want 2 CDCs, or I want for the ESP32-S2, because it doesn't have as many endpoints. Like that might be a thing where like we actually need to say like, oh, I actually want MIDI, because like MIDI is turned off right now, and that's because we don't have endpoints. So this is the oldest open issue, and what this entails is dynamically setting the USB descriptor before a tiny USB is initialized. And one of the challenges with that is that you basically generate the USB descriptor in Python, and then you have to have a process for moving it outside of the Python heap and saving it for the remainder of the run. So it's something I want to get back to, and I think I was actually talking with Lamore. I think it's something we'll probably do next year. What I tend to do in my projects, and what I think Adafruit tends to do, and with CircuitPython we tend to do, is we kind of like orbit. So we do something for a while. We get it to a certain point, and then we want to move off and do something else, but then we'll come back to it. So like displays have done this. Like Jeff was the second orbit for like audio stuff, so like getting MP3 playback. I think for USB, maybe like the third orbit, if you want to talk about it that way, would be dynamic USB descriptors and maybe USB host as well. Specifically for the IMX-RT, because it's really interesting because it has high-speed USB. So it has 480 megabit per second USB instead of the 12 that all the current boards have. So I think this is something we should try to tackle this year if one of you doesn't do it sooner. AP Killer says PwnPy has a default setup. It will be a keyboard and other things, but need to drill the code for that kernel. MP3 would be cool for the car. Yeah, so CircuitPython has MP3 support. So that should be like port agnostic, so it should just work. All right. 343. Any other questions? The one other thing is I was brainstorming what the resolution of a CircuitPython computer should be, and I really would target 1080p, but we don't actually need it that big. So I think I was gonna do divided by 4, so it would be 270 or 1920 by 4. 480 by 270 is what I was hoping the resolution would be. That seems even larger than I was thinking. 240 by... But basically, like, making your pixels extra large. I think maybe it was 480 by 270. So, like... GNU readline support. What's the difference between what we have now? Because we certainly have some readline stuff. AP Killer says it's larger than I ran Doom at. 480 by 270. Yeah. But I like 480 by 270. Like I imagine that TVs are natively 1080p or 4K or even 8K, but like 4K and 8K are doublings of 1080. And so I would really like when we have HDMI support, get on that. What I was thinking is that CircuitPython would render 480 by 270, give you nice chunky pixels, but they would be pixels that match perfectly up to like the pixels of a 1080p or greater screen. VI mode. Yeah, get on that. That's the resolution of the screen I'm putting in one of my dev boards. There's a small screen is that 16 by 9 resolution. You should link me to that. Maybe we should carry it. I don't feel like I've seen screens that are 480 by 270. But I like that. I like that form factor. All right. Let me take a drink and I'll wrap up. Well, thank you everybody for joining me for this deep dive on CircuitPython Day. Sorry I didn't actually get to hacking on anything, but check it out. I'll be streaming next week at, what is the current state of LoRa in CircuitPython? I think it's, I don't know. Ask Jerry. Jerry would know. I think there's a library for it, but I'm not positive. Yeah, so I normally stream Fridays at 2 p.m. Pacific, which is 2 hours previous from now, but on Fridays. And I usually stream for at least 2 hours, depending on how things are going. I might actually, I think the last one I did was 2 hours, 40 minutes, and I actually got to coding. But since we have a hard stop here, I'm not going to like switch modes. And I want to save my voice, even though it's kind of shot. So yeah, check that out. I posted the link to the playlist if you want to watch hours and hours of me talking about all this random stuff. Thank you to everybody for joining me on this special CircuitPython Day thing. We have 2 more streams coming up. We have Show and Tell in 13 minutes or so. And then we have Ask an Engineer as a like group get together, talk about CircuitPython stuff. So that should be really interesting. I'm excited. I don't know what we're going to talk about. We're going to talk about CircuitPython, and as you know, I could talk about CircuitPython all day. So that's going to be super cool. Mark pointed me to the display, which is awesome. So join me for deep dives, usually Fridays at 2 p.m. Check the Adafruit blog for updates on when that's going to happen. Sometimes I move it to Thursday if I take Friday off, but generally Fridays are the days to do it. If you have topics, if you want to get a hold of me, let me know what you're interested in seeing. You can ping me at TanNewt on the Adafruit Discord, which you can join by going to adafru.it/discord. And I guess I should switch to my camera here. Yeah, so adafru.it/discord to chat with me, especially if you get into CircuitPython development. That's a great place to ask for help. There's a CircuitPython channel there it's explicitly for developing and building CircuitPython on your own. So if that's interesting to you, we'd love to have you. Thank you to everybody who's working on CircuitPython and making both the community and the code awesome. We're really bringing more programming to more people, and that's what it's all about. So thanks again. I'll see you in the streams in a couple minutes/hours, and then I'll see you next week for the next deep dive. Thanks so much, and have a great day.